So we see that at a distance of 1 angstrom, the electron would experience approximately this force and this acceleration. Now that's a numerical example. Turns out that the electron can't even orbit at 1 angstrom for reasons that we'll see before too long. Let's do some of these calculations symbolically. Magnitude of the force is kQe squared over r squared. Centripetal acceleration is just the force divided by the mass of the electron. So we just take this expression and throw the mass of the electron into the denominator. The centripetal acceleration, of course, is also v squared over r. So we have two expressions for the centripetal acceleration. We set them equal, and we solve for v. When we do that, we end up with v equals the square root of k over mer times qe. Just multiplying both sides here by r, taking the square root of the qe squared will give us the qe here, and this product will then equal, well, we can rearrange it to say that's the square root of kqe squared over me times 1 over the square root of r. So we see that the velocity is inversely proportional to the square root of r, and the proportionality constant is here. So we have this proportionality. We can evaluate some of these numbers, or we can write the proportionality down here and evaluate this proportionality constant. We see that v is proportional to the reciprocal square root of r. This proportionality constant, if we substitute the numbers in for k, q, e, and me, comes out to be 1.6 times 10 to the first meters to the 3/2 per second. So that if r is 10 to the negative 10th meters, we see that the velocity is going to be this proportionality constant times the reciprocal square root of r, and that's going to come out about 1.6 times 10 to the 6th meters per second. That's 1.6 million meters per second, and that's really moving. And that's consistent with the kind of accelerations that we saw. We have this electron moving at 1.6 million meters per second in a circle of radius 10 to the negative 10th meters, and that's where we get this huge acceleration. Now let's emphasize again, by setting the centripetal force equal to the Coulomb attraction, we obtain this relationship. This is the relationship between the velocity of the electron and its orbital distance. Another thing we can see is that as the orbital distance increases, the velocity is going to decrease. We saw a proportionality very similar to this when we looked at the orbital motion of satellites.